কি হচ্ছে এগুলো? এরকম গোল হয়ে গেল কি করে? বিচ্ছিরি ব্যাপার।
কি হলো?
আমি যা বুঝতে পারছি না এগুলো কি হচ্ছে। মোটা করতে হবে নাকি পেন? Okay. A complex structure on a two-dimensional manifold X is class of where sigma is, that is after the previous one, that is a complex atlas. That means equivalent class of complex atlases. Two atlases are called equivalent if every chart of one atlas is equivalent to is related to another chart of atlas. That means phi 2 inverse phi 2 compose phi 1 inverse is biholomorphic from the corresponding domain of the atlas. Remark: we have a partial order relation on S by inclusion. That is sigma lesser equals to beta if and only if sigma subset of beta, where sigma beta belongs to S, set of all atlases. If we consider a chain lambda such that then union of belongs to S as lambda. This imply and delta. Lambda. This imply hence sorry are holomorphically compatible. So S has mm, this is the end of bracket of this. So S has a maximal element. Moreover, if sigma belongs to S, then sigma star equals to the set of all complex charts or complex charts which are holomorphically compatible to every chart sigma, then star and sigma star is the maximal element of S. So class sigma equals to class, we can take sigma star. This is check. So we may take maximal atlas for a representative of a complex structure. Of a complex structure. Definition. Definition. A Riemann surface is a pair X sigma, where X is a connected two-dimensional manifold, and sigma is a complex structure. Just 1 minute. Convention: if a Riemann surface, if X is a Riemann surface, then by a chart on X, we always mean a complex chart belonging to the maximal atlas of the complex structure. Yeah. Atlas of the complex on X. Okay. So this is number 2 page. How to rename it? How to rename here? Two.
হ্যাঁ তো হয়ে গেছে।
This is very ridiculous. Example: of Riemann surfaces. Number one, x equals to c complex and chart is ID c to c. This is very trivial, and sigma equals to identity complex structure. Okay. Number two, if x is a Riemann surface and y subset of x is an open connected subset, open connected subset, if sigma is a complex structure on x, then sigma y equals to phi such that u to v, phi belongs to sigma u intersection y non-empty is a complex structure of y, hence y is a Riemann surface. Number three, it is called sphere. It is example of a Riemann surface of genus 0. Consider C union infinity, where infinity is a symbol with infinity does not belongs to C. We consider the compact open topology, the following topology: gamma C union infinity. Gamma is U subset of consists of C such that U is open in C union V union infinity such that C minus V is compact in C, usual topology of C. So these are, so you see that my claim is claim C union infinity gamma is a compact Hausdorff space and homeomorphic to S2. hence connected because S2 is connected. Okay. At first, we see that gamma is the topology on infinity. Clearly, phi subset of C open is simply phi belongs to gamma because it is in the set. Since C minus C empty a compact set is simply C union infinity belongs to gamma. Okay. If U alpha belongs to lambda subset of tau, let lambda 1 equals to alpha belongs to lambda such that U alpha of the form V alpha union infinity such that C minus V alpha is compact. Not this. It's compact and lambda 2, sorry, lambda 2 is lambda minus 1, that is those alpha such that U alpha subset of C is open. Then union of U alpha belongs to lambda is union of U alpha belongs to lambda 1 union of U alpha belongs to lambda 2. Now C minus one question in a Hausdorff space, intersection of compact space, arbitrary compact space is compact. Is it true? Answer me. Suppose X is your Hausdorff space and K alpha is collection of a compact set. Then intersection is compact. Is it true or not?
Yes.
Why?
No, we can মানে নেট নিয়ে চেক করা যায় যে একটা ইন্টারসেকশন থেকে একটা নেট নিলাম এক্স আলফা প্রত্যেকটাতে কম্প্যাক্টে আছে ওর একটা সাবনেট থেকে যেটা কনভার্জ করবে সো ইন্টারসেকশনে আছে আর ইউনিক লিমিট হাউসডফের জন্য
I am not understanding you what you are saying, but what are you saying? But let us assume this result. Please check it. Intersection C minus V alpha.
So
Now,
just use the fact that in Hausdorff space compact sets are closed and closed subset of compact sets are compact.
yes, but it is compact in subspace topology.
Huh.
It's infinite. I want to write here infinite symbol. Since the intersection of compact set is compact in Hausdorff space, C. Let compact union of U alpha lambda 2 open, because arbitrary union of open set is open. Then C minus U union V, C minus U intersection C minus V, a closed subset of compact set C minus V. Hence, compact in C minus V. Therefore, this is whole thing is compact. Okay. So union alpha belongs to lambda, U alpha equals to U union V union infinity belongs to tau if lambda 1 is non-empty, equals to U belongs to tau if lambda 1 is empty. So I have checked that arbitrary union also lies on this gamma. Now for finite intersection, can you tell the proof? Tau. Then I put it as homework. Thus, tau is a topology on infinity. Hausdorffness is quite easy. Let AB belongs to C infinity with A not equals to B. If AB belongs to C, then there exists UA, UB open subsets of C with A belongs to UA, B belongs to UB, and UA intersection UB is empty since C is house 2. In the usual topology, metric topology. Okay, this is metric space actually. If B equals to infinity, let B equals to C minus B 0 to mod A closer, then C minus B equals to B to mod A closer compact if A not equals to 0. B belongs to B union infinity and A belongs to UA equals to B A comma mod A, then U A subset of B 0 comma 2 mod A closer if A not equals to 0. So UA intersection V union infinity is empty if A equals to 0. Then we take V equals to C 0 to R closer for any R greater than 0. UA equals to B 0 R. Okay. Thus, C union infinity is house dog. How to show that C union infinity is a compact? How to show? Let is homeomorphic to S2. Then C union infinity is compact, right? S2. S2, what is S2? S2 equals to x0, x1, x2 belongs to R3 such that x0 square plus x1 square plus x2 square equals to 1 with subspace topology. Phi S2 to C union infinity I the stereographic projection, just consider x0, x1, x2 goes to x0, 1 minus x2 plus I, x1, 1 minus x2, and 0, 0, 1 goes to infinity, x2 not equals to 1. Okay. If x2 is 1, rest of 2 should be 0 because sum of square is 1. So it is bijective. Phi is bijective with inverses psi C union infinity to S2, infinity goes to 0, 0, 1, and Z goes to, if Z belongs to C, 2 real Z, 1 plus mod Z square, plus 2 imaginary Z, 1 plus mod Z square, sorry, comma, this is not plus, this comma, mod Z square minus 1 by mod Z square plus 1. Now, check that phi, psi are continuous. How to show? একটা বলো। How to show phi psi are continuous? যে কোনো একটা বলো। Note that topology of C union infinity is compact open topology. Okay, carefully you have to handle it. Anyone?
না, সাইটা তো psi restricted to C is continuous because components are continuous. তো ইনফিনিটির জন্য আমি সিকোয়েন্সিয়াল ব্যবহার করতে পারবো না। তো ওইখানে ইনফিনিটির জন্য বাই ডেফিনিশন দেখাতে হবে।
It is compact open topology, right? Topology is compact open topology. So whenever you are arguing, carefully, you have to careful. I'm giving you 1 minute. Shall I put it to homework?
হ্যাঁ হ্যাঁ
Okay. So this is a check. Now, so far we have proved that Riemann sphere is a Hausdorff. This is claim we have proved. Uh, Assuming the check you have done, so we have proved that C union infinity is the top of compact Hausdorff space and homeomorphic to S2, hence connected. Now, what about chart? Next, we define map phi1 to C identity map, where U1 is C union infinity minus infinity, that is C, and phi2 to C U2 is C union infinity minus 0, that is C star union infinity. Z goes to 1 by Z. Then U1 intersection U2 is, what is that? C star. And phi 1, check it. U1 intersection U2 is phi 2. U1 intersection U2 is also C star. So phi 2, phi 1 inverse, C star to C star. Z goes to 1 by Z is biholomorphic. So it has Riemann surface structure. This is your atlases. U1 comma phi and U2 comma phi 2. This is your atlases. Okay. We'll give more example, but this is compact Riemann surface of genus 0. Later we will see that any compact Riemann surface is homeomorphic to some genus G.
That is uniformization theorem, no?
Yes. There are many versions. Also, the 1 minute just. I'm giving you some definition and properties. Just 1 minute. Yes, some definition. We'll discuss more example. This is just one example I have discussed, just Riemann sphere. You will do the homework. Then we will discuss complex torus and graphs of holomorphic function, and from polynomial how to construct Riemann surface. We will discuss more example and construction. But right now I am giving some definition. Let X be a Riemann surface and X an open subset. A function f y to c is called holomorphic if for every chart psi u to v on the x, the function psi inverse psi y to c is holomorphic in the sense of complex analysis. OY set of all holomorphic function on Y. So this is your U intersection Y, that is psi, and that is C. So F is your Y to C, that is F, that is psi. So psi inverse is your, that is your psi inverse from here to here. F compose psi inverse. That is also C, subset of because you know that this chart goes to C. So C, open subset of C to C, that is your holomorphic. So another definition is suppose we, if we going to definition, we note that OY is a ring. C algebra. Okay. Because sum of holomorphic function is holomorphic, and product of holomorphic function is also holomorphic. So you have a mapping C to OY constant math. Okay, so it is a C algebra. Geo GZ define and F plus G, F G both are belongs to OY. Check, and C to OY there is a map, ring homomorphism. C goes to sorry, Z goes to Z. Suppose a constant P goes to FP, where FP Y to C map, constant map. Okay, so it is a ring homomorphism. You can see that. Now we're giving another definition. Suppose X and Y are surfaces. A continuous mapping Y is called holomorphic if for every chart and with the mapping is holomorphic in the previous sense, or V1 V2 is subset of C in C, in usual sense, that means. Okay, a mapping f x to y is called biholomorphic if it is bijective and if F inverse both are holomorphic. Next day we will discuss main theorem of holomorphic function, that is in a simply connected domain, you see that branch of logarithm exists, and if and only, and next day we will show it. And for any n, if fz not equals to 0, then or any holomorphic function f, you can write that it is fz equals to z to the power k, some gz to the power k. That means if gz not equals to 0 for any k, there exists g1, thus that g1 to the power k equals to gz. Okay. This comes from Cauchy's theorem. And there is some construction how to construct Riemann surface. There is some construction. So we'll do this. At right now, I am Otto Foster is the book. After that, I will shift some later, some other books. Later, I will see. Okay. Any question? রিপন কোনো কোশ্চেন আছে? রিপন, রাহুল?
না স্যার।
তোমাদের কিংসুকদার রিমান সারফেসের কনস্ট্রাকশন কতগুলো করেছে, মানে কি কি করিয়েছে?
ওই তো প্রথম দিনে
রেকর্ডিংটা বন্ধ করে দিতে পারো।
প্রথম দিনে রুট জেড, কিউব রুট, লগ